So we'll try to estimate the mitigation potential in a couple of sectors related to land biosphere, forests, agriculture, and biofuels. So mitigation potential in the forest cover, obviously it's about reducing deforestation and degradation as the first task. And then afforestation, right? If deforestation and forest degradation are already big sources of carbon, as we saw before, then just stopping them is already a mitigation. We can start with the so-called ecosystem services and co-benefits of forest sectors. Socially, they are obviously income sources. They enhance food security. They preserve traditional livelihoods and culture. Environmentally, very important for conserving biodiversity and protection of ecosystem services provided by forests like water resources, erosion control, habitats for birds and pollinators and various animals, etc. In terms of governance, they need to be establishing secure land tenure, increasing transparency and local participation in forest management policies or systems. For example, Lou Del Bello has written articles on how afforestation efforts in India are having some conflicts with indigenous people that depend on forests. Why? Because afforestation is being done without a prior involvement or consultation with these people, or land is being acquired for afforestation without community involvement and so on. But ecosystem services in general is a concept that's easy to define in terms of what services, food, fiber, medicine, cultural value, etc., that are provided by any sectors like forests, mountains, rivers, etc., but coastal ecosystems. But how do you make people value them and preserve them and avoid polluting them or degrading them or disturbing them? That's not always easy. Nonetheless, when you look at potential, you want to make future projections. This is looking at cumulative mitigation potential in global forests from forestation and avoided deforestation, but this also does it at a particular carbon price. Carbon price, as you know probably, is always mentioned as an effective market-based policy which can be equitable, which can generate revenues for favoring further action and so on and so forth, as compared to, let's say, regulation-based policies. The carbon price corresponds to the value you put on reducing emissions, let's say. So if you are a country that is degrading forests and you have to pay for each additional ton of CO2 emitted from that deforestation, higher the value, the more likely you are to try to reduce emissions. Whereas if it's too cheap, then you say, I don't care, I'll just pay the penalty. Right? So this works for industries as well. If industries can pollute by paying a carbon price, then if the carbon price is high, they will try to reduce emissions, but if it's too low, then they might just say, I will just pay the penalty and keep my profits, especially if the profits are going to more than recover the cost of carbon they have to pay. Okay, that's the general idea. So looking here at avoided deforestation, in Asia, Latin America, and different regions here, and in the rest of the world, there is the potential at 2.7 US dollars per ton. You have to obviously remember which year that baseline is from, because the dollar value itself fluctuates, with a plus 5% annual carbon price increment. So in that sense, that takes into account the inflation of carbon price. So there is the potential if you just consider up to 2050, and if you go to 2000 to 2100, there is a significant potential of avoided carbon emissions in terms of petagram CO2. This we have to put in the context of the mitigation that is needed to meet the temperature targets. Okay, how much room do we have in terms of additional carbon we can emit before we hit these temperature targets, like 1.5 degrees with 66% probability, or 2 degrees with 66% probability, or 1.5 with 50% probability, and so on. So what is the role of the forest sector in contributing to that target? This is a more detailed study which takes a model and computes tree restoration potential. So various factors for trees like temperature, soil qualities, precipitation, etc. are considered, and a global map is made in terms of tree cover. So it's showing global potential tree cover representing an area of 4.4 billion hectares of canopy cover distributed across the world. Okay, so this is what is potentially possible if we started to do serious afforestation across the globe. Okay, not considering many things like competition for food, for biofuels, for other urban activities, urbanization, etc., etc. B and C here are showing the differences. So the global potential tree cover from which the subtraction is done for agricultural and urban areas according to two different products, just showing a difference. For example, this product of agricultural land and urban cover produces a different potential for tree cover here versus here. And similarly you can identify regions here and so on. So in this broad map it's hard, but when you zoom in you will see that those kinds of details matter. Why is it important? Obviously agricultural land is very important, and urban areas are important because most of the world is urbanizing rapidly. The urban population is growing and is expected to continue to grow, and expansion of urban areas, especially places like Delhi, Chennai, Bengaluru, and so on, they come at a cost of surrounding villages which convert agricultural land or forest land into urban areas. And here sometimes some forest pieces are kept, but forests get fragmented, which has negative impacts anyway because habitats are broken. So birds, pollinators, insects, various things do not do well when you fragment their habitation. So having an intact forest is not the same as having fragmented forest. Okay. The other big thing is when you look at the emissions from forests, growing forest is important, but protecting them from perturbations or disturbances becomes very critical. So this paper also does risk assessment of future changes in potential tree cover going from -100% to +100%, and identified places like Amazonia and Central African forests and the maritime continent forests, and up here in Siberia and so on, as places for at high risk of change in continuous tree cover. Okay, so these are illustration of expected losses in potential tree cover by 2050 under business as usual climate change scenario, or RCP 8.5, from the average of 3 Earth system models commonly used in ecology. So that's the community Earth system model with different versions, and the Hadley Center model. So quantitative numbers of potential gain and loss are illustrated by bins of 5-degree latitude and longitude along a latitudinal gradient. So the main thing to remember is that afforestation and maybe reaching the full potential of tree restoration can be done if resources are met and conflicts are taken care of and so on. But that's not enough. You have to protect them from future perturbations as well, right? If you look at the human history since the Industrial Revolution, we have done a lot of damage to forests and disturbed and deforested a lot of forests. So red and red plus, reducing emissions from deforestation and forest degradation, is obviously an important factor in these kind of issues. So there is the mitigation potential in forest sectors. It can be significant, but we have to keep in mind all the other feedbacks and constraints and conflicts with other demands like food security, urbanization, agricultural land, and so on. So we will look at this in various other ways like natural solutions and so on, which include forest as well as other land use types. But let's just leave this potential for mitigation in forest sector here.